I welcome you all in this lecture on simulation using Simulink, which is a sub module for modeling and simulation of dynamic system course. So, we have seen that how we write the mathematical model for the different dynamic systems, and once we have mathematical model, the next task is to do the simulation of that model. So, we have earlier also seen in my earlier lectures transfer functions, and then block diagram algebra, signal flow diagram, signal flow graphs, etc. So, simulation using Simulink is basically something very similar to manipulating of the blocks, okay, that is the block diagram. So, this Simulink is a toolbox to model system in a block diagram form, as I said, and it is part of the MATLAB basically. So, after opening the MATLAB window, if we type the Simulink, okay, a new pops up with the name of Simulink module comes, and Simulink module and elementary blocks appear. So, basically when you are going to open the MATLAB, you will be getting a prompt like this, and here in this prompt you have to type the Simulink, okay. And once this Simulink module and elementary blocks appear, then one can select a new model from the drop down file menu, and after selecting the new model, another window will appear, and where we can draw the block diagrams. So, the Simulink has got the graphical block diagram capability. We can drag and drop components, different components one can drag and drop, and these components are called blocks, and there is extensive library available for the blocks, okay. For example, DSP block set is one, that is digital signal processing, that is there, and then there are the real time workshop blocks are also available. In this environment of Simulink, we can model the continuous, discrete as well as hybrid systems, and we can also do the modeling for linear and non-linear components, and it is very closely integrated with the MATLAB and the other toolboxes. So, the Simulink model typically consists of three basic blocks. One block is the source, another is the system, and then you have the sink. So, the source is basically, sources are basically the input blocks, and sink are what you can say that the output, where we see the output, and then there are system blocks, okay. So, in the system blocks there are interconnection of linear and non-linear block. Those linear and non-linear blocks forms part of the system. Now, coming to the sources, there various type of sources are available in the library, say sine wave, function generator. You can get those sources from the MATLAB workspace as well, and from the disk files. Also these sources can be one can have, and the sink has got display scope, okay. FFT scope is there, then it can go to the MATLAB workspace also, and it can also go to the disk file. So, these features are available in the Simulink. You can just broadly speaking, what I can say is that we have the sources where we can incorporate different types of sources in the model. We have the sink where you can visualize your output, and in between and sources and sink you can have system blocks where you can use the linear and non-linear blocks available in order to create your Simulink model. So, say a simple Simulink model may look like this, something like this. Here this portion basically, this portion the sine wave, this is basically your input, okay, and the scopes which you are seeing. So, these are basically the sink. So, you have the source and sink, and then various blocks has been used here in order to create the system model, okay. So, like this you will be seeing in all the Simulink model, there will be scopes, sink and sources, and then various linear and non-linear elements are there. Say here there is a unit delay is there, some gains are there, again some gains are there, some summation of these signals are there, all those things. Now, Simulink block library basically contains components that can be used for the building of the blocks, okay, and this block library can itself has other libraries as block, okay. For example, here you can see that you have a source. So, in this source you can have the various types of sources available. Then you have the sink, and this sink, if you have look at this sink, then in the sink you can have say the scope, your XY plot graph is there, display is there. If you want to take the output to some file, so that is also there, some workspace if you want to take, or if you want to terminate your simulation, then there is a stop simulation block is there. So, these all forms part of the sink. Likewise, your sources can have various sub blocks, discrete, linear, non-linear, okay, all those things are available. Now, if you have to build a Simulink model, then actually this is our model window, where we have to pick the blocks and place it here over here and do the connection between the different blocks. So, this is our model window, and say this is our source library available, from where we can take the various sources, say sine wave if I want to take. So, I can drag it over here. So, sine wave. Similarly, the model window, I can have the linear blocks library, where I have say summation, gain, integrator, transfer function, state space, zero pole, derivative, dot product, matrix gain, slider gain, all these things are available. So, I can take one here, that is linear blocks for creating the system model, and from here I can take the source, fine. And then once we have say the source and we have the various blocks here, all right, and say we have the scope, that is the sink, we can do the connections between these different blocks, okay. So, we can use the left mouse button to click on a port and drag for a connection, all right. So, this is how we can do it, and we can use the right mouse button to click on a line and drag for any branching if you are interested in, or if your model contains some branching, so that you can do, and that way we can connect the different blocks and create the model consisting of the source, sink as well as the systems. So, let us look at little more something about the Simulink basic. We can double click on a block to open its dialog box, and parameter for the block can be set in this dialog box, okay. For example, if I am talking about some input sine wave source, then I can set the amplitude, I can set the frequency, I can set the phase, and I can also set the sampling frequency of the sine wave source. So, all these things I can do, and after selecting the block, one can rotate, flip or resize it. These operations are useful in creating a more readable block diagram, okay. Then how can we set the simulation parameters, okay. So, in order to set the simulation menu item of the model window can be used to set the simulation parameter. You can, in this simulation parameter, you can specify the appropriate solver that is to be used. For example, for discrete time steps, we can use say fixed step discrete solver if there is only a single sample time, or we can go for the variable step discrete solver if there are multi-rate system. Okay. And you can also specify the variable that can be obtained from or returned to the MATLAB workspace. So, all those things can be done. Then we can create the various subsystems. Okay. So, one can select the portion of the model using the mouse and make them into a subsystem. Actually, creating subsystems many times helps us in debugging, actually, that is finding out of some errors in your model. So, you can create some of the blocks and you can make those blocks as the subsystem, and also we can create or mask a subsystem that hides the complexity of the subsystem from the user. So, this also can be done. Let us take an example. Okay. Say I want this system to be simulated, and this system contains a source here which is a step source. There is a scope here, okay, that is the sink, and there is a system here. Okay. So, this system is again some transfer function. So, as I have been telling you, this model consists of 3 blocks. One is the step source block, this is the source, then the scope sink block, that is this is the scope sink block, and there is a transfer function linear block. Okay. So, these things are available. So, now let us see through this example the various features of the Simulink. Now, a block can be modified by double clicking on it, hereby right click on the transfer function block yields. Okay. So, if you are going to right click on the transfer function block, you are going to see this window where basically you specify what is the numerator and what is the denominator of the transfer function. Okay. So, here say numerator is 1 and here it is denominator is 1 1, and this 1 1 basically means that it is s plus 1. Okay. So, this is what here we will be getting if we are putting it like this. Okay. So, this is the numerator and the denominator 1 1. Okay. So, this way we can specify the transfer function. Here see you get a help also where it is written that matrix expression for numerator, vector expression for denominator. Okay. Output width equals the number of rows in the numerator, coefficients are for the descending power of s. So, this is what is given. Now, to change the denominator says to say s square plus 2s plus 4, if I want to put it like this s square plus 2s plus 4, here instead of 1 1 what we have to write is basically we have to write 1 2 4 here. Okay. That is the coefficients in the decreasing order that you have to specify 1 2 4 in the denominator field. Okay. So, that has to be specified, that is here in this denominator you have to write 1 2 4. So, if you do that you will be able to get this transfer function s square plus 2s plus 4. Okay. Then so this was about the setting the transfer function, okay, in the system block. Now, let us see the setting of the parameters in the input or source. So, the step block can also be double clicked, bringing up the following dialog box. So, if you double click on the step block, this will be the dialog box which you will be getting, where it says that outputs a step parameter. Here step time is there which is 1 second, initial value is 0 and the final value of step is 1. So, here we can play with it, we can modify it. Okay. So, the default parameter in this dialog box generate a step function occurring at time 1 second as specified from an initial level of 0 to a level initial value of 0 to a final value of 1. So, this way we can set the source. Okay. So, this way we can set up the source. Previous slides we set up the transfer function block. Then if we double click on the scope block also, it will bring up a blank oscilloscope screen. Basically it is a output screen which is there, and which is also called the oscilloscope screen that will be coming here, and when a simulation is performed, the signal which feeds into the scope will be displayed in the window. Okay. So, when your simulation is running, the whatever signal which will be coming here, the output signal, that is going to be seen in this window. So, take the following model to run for the simulation. Let us take this model, that is, you have a step 1, step source, there is a scope, and say transfer function is there, that is 1 by s square plus 2s plus 4. Now, before running a simulation of this system, first open the scope window by double clicking on the scope block. So, first you have to open the scope window by double clicking on this scope block, and then to start the simulation, select start from the simulation menu. Okay. So, we have this simulation menu here, and on this simulation menu you have to select the start, then simulation will take place. Okay. So, this is how it looks like. You have to click on this simulation and go to the start and click here. Okay. And after you click here, the simulation should run very quickly and the scope window will be appearing. Okay. So, you will be getting the scope window and the simulation will be running. So, this is how it turns out to be. Okay. So, this is your scope where you will be seeing one yellow line something like this. So, the simulation output shown in yellow here is at a very low level relative to the axis of the scope. Okay. And to fix this, to see the proper values here, okay, what we can do is that we can hit the auto scale button, or which is also called the binocular. So, you can hit at the auto scale button and or the binocular, and you will be able to see the true variation. Okay. So, this is how your things will be seen by going to the auto scale button or the binocular, you have to hit it, and this way you will be able to see the variation. Okay. So, this is how one can do the simulation using the Simulink. Okay. So, this is basically, as I said, it is a block diagram type of approach for doing the first you create the model of the system, and then after once you have created the model, then you can simulate that model after specifying the input and the system parameters. So, what are the your inputs and what are your system parameters? If you specify these things, then you can see the output something like this. Okay. So, this is a simple example I have taken, and during our this course I have been discussing with you the many types of the Simulink models. So, this is the basic procedure which will be applicable for any types of Simulink model. Okay. So, if you want to try, you can make you can create a Simulink model in order to simulate say our well known system, say mx double dot plus bx dot plus kx is equal to say ft. Okay. So, you can simulate for free as well as for the force vibration case for this system, and you can see the behavior. Okay. And again here what I will suggest is that you go for say mx double dot plus bx dot plus kx is equal to 0. So, get the transfer function for this case, okay, and then do the simulation and find out or observe all the 3 cases depending on the values of m, b and k, that is the overdamped, critical damped and underdamped. Okay. So, simulate for all these 3 cases, create the Simulink diagram and simulate for all these 3 cases by choosing the appropriate values of m, b and k. We can change the parameter of the simulation also, as I was talking to you, and in the model window select parameters from the simulation menu, okay, and you will see the following dialog box, and in this dialog box you see we have the start time, stop time and solver option, you have the variable step, and here what that is ODE 45 solver you are using. So, here various solvers are available and you can choose the appropriate solver from here, okay. And of course, maximum step size, this initial step size has been given auto, related to some tolerance has been specified, and output option has been given, okay. So, this way we can change the parameters of the simulation also, okay. And say in the previous one if I change this time, say stop time from 10 to 2 seconds, then of course we can by changing the stop time from 10 seconds to 2 seconds, this is what we get, and here of course this is our the amplitude, okay, and this is our 2 seconds, okay. So, this is how your you get the output. So, this way we can do the simulation, and if you want to practice further, you can go through the following reference, that is the math work help book on Simulink dynamic system simulation. Go through this help book and you will be seeing many more examples and many more cases available here, and practice it yourself. Thank you.